All right. Good afternoon, guys. So, how going? Yeah. So yeah. So the session will be recorded. So don't worry about that. So my name is Saba Antombi, and I'm going to be taking you through what you call quality management systems, right? And our first lab will be on ANOVA. And so in this lab, we'll be using Excel. And so under practicals, I've uploaded like a guide and data that will be used for for the practice of this lab. And so now the data is under data and the guide, they're under practical. So if you can like just go to them now, I'll give you 2 minutes. Okay, so I assume all of you have found the guide. And okay, so like and also like I assume that you've went over like ANOVA with me in class. That's a correct assumption. So you didn't even go over ANOVA, like okay now she so like, she told me that she gave you ANOVA as a self start. Yeah. So now I'm gonna go over like the key things that I want you to understand before we start this lab, and then yeah, you do the rest on your own. So we use ANOVA like when we want to analyze data in such a sense that we want to compare compare the variation between two different groups, for example, right? So if maybe what you call like maybe we take industrial and mechanical and we subject them to maybe the same type of conditions, right? And see how like what would be the variation between the two groups, right? So we use ANOVA like for purposes like that. But in the context of what you call of industrial engineering, we use it like to can I put this? So like let's say we're trying to identify like a sort of variation in a process, right? So we can look so again you know that like random variations like we don't count them like in when we're doing when we identify source of variation. We look for assignable causes, right? So this is a way like to determine what those assignable causes are. And so for example, like you may take an operator, a scale, and what you call operator scale, and the third one, and a part or a product, right? Those three, right? And then let's say we have three operators. So and then let's say a scale 2 kg, right? And then you take the operators, you make them measure whatever the product is on that scale. Like and then you see maybe like they'll get variations, they'll measure the weights different, right? And then, like from that on, you can use that data and then perform what you call statistical analysis to determine which one of the is it the part that was produced from the process, or is it the operator, or it's the what you call it's the scale that's causing the variation. Right? So now one other thing. So yeah, so what we'll be doing in this lab, and then it's what you call it's called Gage R&R or measurement systems analysis, right? Which is basically used for like what I just told you. So like when you want to determine the source of variation in a process, right? So if so like initially you take what can I say? Yeah, as I explained, you'd have a process that's producing, let's say Coca-Cola, for example, they're producing maybe 2 liter bottles, and then you take three operators, for example, let's say an experiment. Take three operators, and then you make them like they will stand in line, and then there'll be a scale, and then as they are producing, they want to measure those quantities, right? They want to get like differences, like most of the time. And those differences, maybe you repeat the experiment maybe like 20 times to make sure like that the experiment or the data is valid or it has validity. And then from then on, you come to what you call to do ANOVA or Gage RNR. So yeah, and then from when you do what you call when you do Gage RNR, and then like what helps us determine the cause of variation is something we call the p-value, right? So you'll see it as we do our analysis, but like if you what you call in your analysis you get a p-value that's less than 0.5, it means that that particular that particular variable is what's causing the variation. And then a variable that's, let's say, yeah, if you get yeah, and let's say if you get a what you call a p-value, the lowest p-value, like yeah, the lowest p-value, it gives you the variable that's the cause of the variation. And then the second variable after that, it's significant, which means it affects variation to some extent. And then the one with the biggest p-value, it will be insignificant, which means it doesn't cause variation at all, which is not a problem at all. And then so now I want us to what you call. I hope you've downloaded the data that I uploaded the guide and the data. So if you go what you call, yeah. So yeah, this data here, and then so okay. But before we what you call before we like focus on the data, and then I want you to go to file, and then you go to options, and then so you go file options, and then you go to add-ins. You go to add-ins, and then so yeah, is everyone still following? And then from add-ins, you're gonna select what is called an analysis tool pack. This one here, it's written like this, analysis tool pack. And then are you still with me? And then you're gonna press OK, you're gonna add it in. And then after you add it in, if you go to like under your data tab here, you wanna see like like an option like for data analysis tools, and it's like this, looks like this, or a solver. You go to as I said, you go to account, not account, sorry, you go to options, and then add-ins, and then you click on it, and then you press OK, or yeah, or you press go then, yeah, okay, yeah, you press go, and then you press OK. What? So do you all have it now? Okay, so under here, right? So if you can see like the data in here, so we have what you call, we have three operators, right? And then those three operators, like they use the same string, and to first, like this is the first experiment here. So let's say they were measuring like something like that's maybe what that weighs maybe 20 kg, and so the operators measured that particular part or product 3 times, and then the second operator also measured it 3 times, and then they repeat the experiment like 10 times, and so like these are the measurements that they got like from the scale that they were using, right? And then from then on, how you now like do your analysis, and then is that you go to data analysis, and then from here you'll get a different set of options, and then there's ANOVA single factor, and then there's ANOVA two-factor with replication, and then there's ANOVA without replication. So use ANOVA without replication if you only like if the operator only measures like the part only once, and then you all understand that. And then so since here they measured it 3 times, you're gonna select ANOVA with replication, and then this one here, ANOVA with replication, and then you're gonna press OK. And yeah. So you go to you press on data analysis, and then on data analysis you're gonna get a different set of options, and then I said like if so like the ones I want to focus on is the ANOVA two-factor ANOVA. So there's ANOVA with replication, and then there's ANOVA without replication. So now if you only let's say reset the experiment only once, which means the operator only measured once, and then you wanna use without replication. And then if the operator, if you like you repeated experiment like more than once, you wanna select with replication, and then okay, and then from here you wanna select the input range, and then which is from here up until towards the end here, and then make sure you select the data. I still with me. And then here, since like they repeated the experiment 3 times, and your rows per sample is gonna be 3. Do you all understand? Right. And then like your alpha value, like it mostly like it's usually 1.5, 0.05, and like it's maybe like related to like confidence intervals and whatnot. So like which means like I can say like we assume maybe that like data has a 95% confidence interval if our alpha is 0.05. But I'll always give you the value of alpha. And then here, like it's fine. Like you can say like the data can be generated in a new worksheet. And then after you press OK, right? So you're gonna get something like this. And then did you all get that? So like after you get this, and then so who didn't get this? So now after you get this, and then so guys, can I continue, or you're still trying to? Okay, so yeah. So here, like this is the result of your ANOVA or your ANOVA table, and then, so in your ANOVA table, like this is your final ANOVA table. So now what you wanna focus on when you get here, it's your what you call it, it's your P value, as I said. So now we are trying to identify the source of variation, and then, so if you look at your but now before we move to the P value, and then, so if you come back to a table, and then where's your table? Your table, and then if you look at the column here, it's the operate, and then, so which means here your column is gonna be operate, and then so if you look at your data, and then like the columns, like they are operated, like they are different operators, and then, which means this side, and then your columns are gonna be the operate, and then your sample, and then your sample is gonna be the part or the product that you measure, and then so that's your sample, that's the part, and then are you still with me?
When they can help you to get that source.
Guys, when you are selecting the data, when you put the heading, starts like from the data, right? Don't put the headings. So try selecting the data without like including the headings. Fine. Okay, yeah. So since you've addressed that, like Can I continue? So do you understand, like, when I said, like, this, your sample is your part that you are measuring your product, right? And then your column is the operator, and then your interaction, and then is the, like, it's the part process interaction, and then, like, which means it's the product. So it's the, yeah, part process interaction or the part operator interaction, which means it measures or it looks at what, like, combines the part and the operator. In this case, it's the scale, and then that they are using to measure. Or, like, in this terms, I'll just to call it a gauge. It's a gauge. So when I call it a gauge, but it's similar to a scale. Do you all understand? Okay. So now, since you have identified that, like, now your part, your operator and your gauge, and then now you want to look at their p values, so now if you look at your p values, and then so now you look for to identify the source of variation, and then you look for the one with the lowest p value, right? Preferably that approximates like zero. But yeah, the one with the lowest p value is your cause of variation. So now from here, and so okay, let me try and zoom in here. Here. I hope you can all see now. So you look for, like, now we're focusing on p value on here on this column, and then we're trying to identify source of variation. So now how you do that, you look for, like, the one with the lowest p value, and then the one with the lowest p value is your source of variation, so where it's just causing the variation, and then, which means in this case the one with the lowest p value is the operator, and then, which means the operator is the source of variation, and then the and then, as I said, like, if you still remember from here, and then, like, if, like, there's a cause of variation, there's a variation that's significant, and then there's a variation that's insignificant, and then if, what you call, so now this one with the highest variation is insignificant because it doesn't have, yeah, it doesn't cause variation at all, and then the one with, like, the one with the second, what you call, yeah, the second highest, or the middle, yeah, I can say the middle, the gauge, it's significant, but, like, it's not the main cause of the variation, so now from then how you conclude, and then you want to say, like, from the ANOVA table, the, what you call, I identify the cause of variation. Okay, so let me just type it down. Yeah. Yes. So how many shifts do you get?
Which one that you need to know?
You're supposed to get one sheet.
Yeah. It's
Yeah. It doesn't.
yeah.
Oh, that was already sheet two. Okay, so yeah, so that's my mistake, and it's supposed to generate one, like, supposed to generate one sheet, and then, so from here, and then you'll say, like, from the ANOVA table, the cause of variation can be identified as the operator, since it has the lowest p value, and then p value of, and then you state the number, which is 0.0.07826, and then like from then, like, and then now you continue, like, to say, like, the what you call the part, or yeah, the part is insignificant, since it, like, it has the highest PV. You state the number, and then you also, like, also state, like, we have state that whether it's significant or insignificant. Since it has the highest number, you're gonna say it's gonna be insignificant, obvious. And then the middle one, and then you state it's PV, you also state whether it's significant or not. And then, so one thing I wanted to know, and then, is that, like, if, like, the p value, and then exceeds 0.5, and then, like, both, like, let's say maybe your part is the cause of variation, and then, so yeah, wait, let me just say what you call, let me, so, like, let's say, like, 0.5 is your threshold, and then, so now, like, what you call, like, variable p values that are less than 0.5, they are always cause of variation, but once they exceed what you call, once they exceed 0.5, they become insignificant. So, like, now you may have two, what you call, two variables, that are significant, but they have maybe a higher level, like the other one has a higher level of significance than the other one. I don't know if you get what I'm saying. And then if, what you call, like, if your PV is less than 0.5, and then the other values are greater than 0.5, it means, like, the one that's less than 0.5 is the cause of variation. You all understand? Okay. And then, so now, like, another thing that I wanted to know, is that, what you call, if you ever identify what you call your gauge as the cause of variation, and then, like, your results, like, you have to conclude at the end, after you state whether, you have to conclude that your, what you call, your your result will be reproducible and repeatable. And so now, if your gauge is the problem, and it means, like, if your gauge is constantly producing, like, wrong results, and it means that your experiment is not repeatable and reproducible, and that happens if your gauge is the source of variation. And then if your gauge is not the source of variation, the experiment is always reproducible and replicable. So, like, how you conclude, like, or how you state that, and so to check something. So you'd say something like this, or here, yeah, your results are not repeatable and they are not reproducible. Yeah, you can't replicate them because the gauge is constantly going to give you, like, wrong measurements. So you can't repeat that. There's something wrong with the gauge. So now, like, you say something like this is something like the conclusion that, like, you would make, and something like this. So you'd state the p values, identify which. So now, for example, you check the one with that causes variation, and then define the operator and its p value, and then towards the end, if the gauge is not the problem, say we conclude that the gauge measure, if the gauge is not the problem of variation, or not the cause of variation, you'd say towards the end, we conclude that the gauge measurement is repeatable and reproducible. And then, but if the gauge is soft variation, the results are not repeatable and reproducible. You understand? Okay. So, yeah. Yeah, I think what that. Yeah. So, let me say something. Wait, let me say something. Okay, yeah. But if you have any questions, you may come from
7 days to consult. Next week, write it.
wait. Next week we are right. Next week Friday, around this time. So, yeah.
Okay, what you say?
Yeah. I use, like, I use Logic.
Okay.